problem, we'll be examining how shifting a function and stretching and compressing it will affect it, and we'll demonstrate how you get that resulting equation. So in this case, we have a given x squared plus y squared equal 4, which is a circle with a radius of 2. So we can go ahead and draw it. It's at the origin. And the first thing that we do is shift it 2 in the x. So x. So we have 2. Shift again, and the y. It's going to be down 1. Next thing we do is going to be compress in the x direction. Factor of 3. Fourth step we're going to do is stretch in the y direction by a factor of 2. So first we're going to shift it over to the right and then down 1. So our basic equation is x minus h squared, or minus 0, or h is 0 in this case, for x squared plus y squared, plus y minus 0 squared equals 4. Shift it right, shift it down. So it's going to be x minus 2 squared plus y plus 1 squared equals 4. So that's 1 and 2. We can do them together because x and y are independent of each other. And then we can do step 3 and 4 together as well because, again, x and y are independent of each other. For compression, we increase our factor of our coefficient. So the coefficient of x will go from x to 3x, and then for stretching, we decrease our factor or our coefficient. So for y, we'll go to y over 2, which makes our new equation 3x minus 2 squared plus y over 2 plus 1 squared equals 4. So this number here is determined by your factor, and then whether or not it's a number greater or less than 1, this is determined by whether or not if you're compressing or stretching. Compressing means it's a greater than 1, and stretching means it's less than 1. So this is our final equation. So we're going to do the same thing, but instead we're going to flip 1 and 2 and 3 and 4. We're going to compress and stretch first. So we do the same thing. We're going to compress and stretch first. So that makes it 3x squared plus y over 2 squared equals 4. And now when we go to shift, we have our factor in front that's going to affect it. So it's going to be 3 times x minus 2, since that's how much we're shifting it over, close parentheses, squared, plus our factor on the outside, 1/2. It's going to be y minus k, so our new k is going to be plus 1. Or I guess k is going to be minus 1, which makes it y plus 1, close quantity, squared equals 4. So the biggest difference is that we now have this factor of compression and stretching affects the h and k now instead of just our x and y. Since we stretch and compress first, it's going to affect both. But in the first one, since we shifted first, it didn't affect it, but now it does affect it. So biggest difference here, no effect on this. Now it has an effect on both. And this is our final equation. You can leave it as is or expand it if you like, but this is just fine. All right. So our next problem. So our next problem is to find the direction of v So whenever it says find the direction of something, it really means find the unit vector, because a unit vector is primarily a direction. It doesn't give you a magnitude because its magnitude is 1. So it says find direction. It means find the vector v over the magnitude of itself. So this will equal 3i minus 2j over the square root of each of the components squared. So 3i squared is just going to be 9, and then negative 2j squared is going to be 4. So this will equal 1 over the square root of 13 times 3i minus 2j. So this has a magnitude of 1. So what we're really getting is just the direction of the vector. We don't have a magnitude of it because the magnitude is just 1. So we have just a direction. So anything we multiply to this in terms of magnitude will take on that new magnitude. Hence, this is why it's a unit vector, because this has a magnitude direction of has a magnitude of 1, but its direction is what's most important about it. That's because anything you multiply to it will be that new number. Now, it says if theta is the angle v makes with the positive x-axis, cosine theta should equal what, and sine theta should equal what. So we're going to rethink about this in terms of just components to a triangle. So if we're looking at the x component, it'll be 3 over square root of 13. 3 over the square root of 13 is our x component. Our y component is negative 2 over square root of 13. And our overall hypotenuse is just 1. So if theta, this right here would be theta, because it's with the x, it's with the positive x-axis. So if this is the origin here, then this would be the positive x-axis. So our cosine theta would be our adjacent over our hypotenuse, which would equal 3 over the square root of 13, and it'd be over 1, so we can just leave it as 3 square root of 13. And then sine theta would be opposite over hypotenuse, so it would be negative 2 over square root of 13 over 1, so it would just be negative square root of 2 over 13. Now it says find a vector of length 2 in the opposite direction. So if we know that v over the magnitude of v has a magnitude of 1, that means if we wanted to have a new vector, here, we'll call this vector prime. If we want to have this new vector where it's double the magnitude of v over square root of v, v over the magnitude of v, so that would be 2 times that vector over the magnitude of the vector. Or you may see it as 2 u caret. So the caret just means it's a u vector. That's why our i's and j's have it, because they are a magnitude of 1 as well. They are unit vectors. So, and then since it's in the opposite direction, it must also be negative. So all I have to do is multiply by negative 2 to our vector v over the magnitude of v. So we take our negative 2 and multiply it to 1 over the square root of 13 over times 3i minus 2j, and then it would equal 2 over the square root of 13 times negative 3, that should be I, plus 2j. All right, so this is our final answer here. So this next one, we have to find a and b such that a vector plus b vector equals 2i minus j. And we're given a vector and b vector. So we need to find this using essentially a system of equations. So a times a vector, which would be 2i plus 3j, plus b times b vector, which is 4i plus 2j, plus equal to vector 2i minus j. So this is a similar process as from when we had to solve for x and yi. In this case, instead of separating it into real and unreal, we're going to separate it into I and j equations. So we have an I equation and a j equation. So our I equation is going to be a times 2i plus b times 4i equals 2i. So I have a 2i plus b 4i equals 2i. Since i's are in common for each of these terms, we can cancel them out, and we essentially just have 2a plus 4b equals 2. For our next equation, we have a times 3j, b times 2j equals negative j. So we're going to have a 3j plus 4 2j equals negative j. Cancel our j's, just like we did with i's. And then our equation is going to be 3a plus 2b equals negative 1. Now you can solve for a system of equations. So there's several different ways you can go about it. I normally like the cancellation method. So here I see that there is a common factor of 2 here. So I can't, I'm going to take out those 2's, so then I'm left with a plus 2b equals 2. And then I have 3a plus 2b equals negative 1. I can then subtract this equation from the other equation. When I left negative 2a, cancel out my 2b's. This will equal 3a, so equals 3. Which then means a equals negative 3 halves. Which then implies b to equal, so we have a, so I'll just pull up another, I'll go over here. So we have negative 3 halves plus 2b equals 2. Oh wait. Whoops, forgot to factor out. That should be a 1. That should come out to being 2, which then means a equals negative 1, which is way easier. Sorry, forgot to factor that 2 there. Then if a equals negative 1, then that makes negative 1 plus 2b equal 1, which means b must equal 1. So that's my answer.